Recently, I released my latest procedural assets pack, Engine FX, which allows you to create your own procedural engine thrust effects. So, in this video, I'll go through the basics of creating a thrust effect from scratch. In Engine FX, we have what I call building blocks. This contains a bunch of shader groups and geometry groups that you can use to create your own effects. Add a new object to the scene and create a new geometry node modifier to it. This new modifier setup will be our new preset. Then drag and drop the basic tail geometry node setup. This is the most basic effect in the asset pack. Go to render view. Here for this tutorial I work in Eevee. This setup gives me option to change the tail shape, glow color and strength. So how did I create this? Let's see. It all starts with a curve line node. In the FX pack, I set the default thrust direction to the positive x-axis. So I set this direction to 1 on x. The length value will control the overall length of the tail. We will need more resolution to the tail, so add a resample curve node after this. Then to add width to the tail, I add curve to mesh node. For the profile curve socket, I use a duplicate of this curve line. This length value will work as our tail width, but I want the tail to be centered when we change the width. We need a way to adjust this start value based on the width we give. For that, I add a value node, rename it to width. This will work as our width input for now. Plug it into the length socket. Then I can use a math node, divide it by 2 and multiply it with a -1 to get the x offset. Or we can do it in one go by simply multiplying it by -0.5. Since our start is a vector input, I drag from here and search for XYZ and connect this to a combined XYZ node. Then plug that to start. Now you can see our tail is always centered. Let's move on and tinker with the shape of the tail. For that, you can use set curve radius node and change the radius of the main curve. Plug a spline parameter node into the radius. Since it gives 0 to 1 gradient along the curve, you can see it did this to our shape. Then I use a float curve to adjust its shape like this. But what if you want a shape like this? In my basic tail setup, you have the option to blend between these two shapes. So let's create that function as well. It's very simple. Just use a mix node and plug these two shapes into A and B and output to the radius. Use this factor value to blend between the shapes. I add another value node and call it shape. Plug this into the factor. Now, what if you want the tail end to be not pointy? Well, you can use a add math node. Check this clamp box so that value doesn't go beyond 0 to 1 range. Then just change the add amount. Or you can use a different method. Just duplicate this next node, put it here and change the B value to 1. Now when you change this factor, you can see it blending between the shape we created earlier and the max value of 1, giving us control of the pointiness of the tail. Duplicate this and do the same for this factor as well. I call it end shape. Let's see the basic tail geo setup to see what we're missing. You can see when I change the width and the length of the tail, it is changing its resolution to give the best possible topology without stretching much. This is happening due to a simple setup I created here. This is important and you will see why a little later. Now let's create a material for this. I call it tutorial basic tail. To add it to the setup, use a Set Material node. Let's go to the shading workspace and work on our material. I open a window here to access our assets pack. In Engine FX, you not only get to create the shade, you also get to create your own material for them using these shader groups. So let's see this basic tail shader group. We don't need the principal shader. You can see it is not working, and it is because the tail we created from scratch actually missing a few key elements, attributes. We need to pass these few attributes between the geometry editor and the shader editor to make these materials work. By default, you don't need to worry about this because these geometry setups come with those attributes. But since we are creating one from scratch, we also need to create them as well. The first one is what I call tail UVs, which is basically a UV map for our tail. This is something I have done quite a few times in my previous geometry node videos, so why not let's do it again. First, I add a capture attribute node to our main curve and capture spline parameter factor. Then I do the same for our profile curve as well. This way we can grab the 0 to 1 gradient of the length and the width and use it as the x-axis and y-axis of our UV map. Now to store this as a UV vector, I add a store attribute node and call it tail UVs. Make sure to change the type to vector. Then drag from this vector and search for combine XYZ node. Now you can plug this into X and Y to create the UV map vector. But here for the X-axis, I like to change this value a bit. Since our tail goes from here to here, it is easy for me to reverse the gradient now. Otherwise, I will have to do it countless times in the shader editor. So let's do it here. There are a few ways to do it. You can use a color ramp or a float curve, but here I will use the 1 minus method. Just subtract this parameter factor value from 1 using subtract math node. This will reverse the gradient. Now to use it here in the shader editor, add an attribute node and type the exact attribute name you gave in the geo setup. If you had to do this when you use in the FX pack, just match the name after the capital A in the brackets. This A stands for attribute. Now plug this into tail UVs and still we can't really see the material. That's because in Eevee we have to change the material alpha settings. Change this blend mode to alpha blend. And look at that. You now created the basic tail material. Here you can see these little issues. I can fix that by adding a sample curve to the profile curve and giving it some resolution. We still have a slight issue here. We need that dynamic resolution I talked about earlier. But I will come back to that later. Now let's go to our material and build this basic tail shader from scratch. I start with our tail UVs. Separate its axis. Let's deal with the y-axis first. I use a color ramp and adjust it like this. You can use the B-spline method for creating a more smooth gradient. These black areas will be transparent. Now do a similar thing to the x-axis as well. This time I keep it like this. Then use a multiply math node to combine these two together. Add an emission shader and a transparent shader to the setup. Hold Shift, Control and right-click drag from the emission node to the transparent node to create a mixed shader. Now plug this into factor. Black areas will be transparent and white areas will have the emission shader. This is our basic material. You can change the emission color and strength to control the glow of the effect. Now let's deal with that issue. Although it looks fine at the moment, when we start changing the length and width of the tail, these resolution numbers probably will not work with that new shape. You might see some stretching. So we need to create a setup for the width that dynamically adjusts its resolution based on the resolution we have given for the main curve. Here I duplicate the value node twice and call them resolution and length. This will reference our main curve's resolution and length. I start by dividing the length by the resolution. This gives me when to put a loop cut. Right now it is about 0.1. That means for every 0.1 meter on the main curve, there is a loop cut. Then I divide our width by that number to see how many cuts I need for the width. It says I need around 10. But you can see that number is actually a float number with decimals. For our resolution, we need an integer. So I duplicate this math node and change it to either round or float. Here it rounded that number to the nearest integer, 10. Plug this to count. Since I already had 10 there, let me change it to 5. Now when I plug it, you can see it immediately adjusts. Let's extract some necessary values. I am going to delete this geometry input. We don't need that. I drag our length and count to the group input node and change the count name to resolution. Let's extract these two as well. Since factor is a slider input, here we also going to get a slider input in the modifier. I call them shape and end shape like before. You can set their min and max values to 0 and 1. Now I duplicate this again and let's extract width. I create a reroute node here and drag this to extract a new input. For these two, I duplicate the group input node again, and since we already extracted the length and resolution, I just plug them here. And now when I change these values, you can see we have that dynamic resolution. Let's create a way to control the glow color and strength from here. I create another input, set its type to color and call it glow color. I make it orange. Create another input, this time a float, and call it glow strength. I increase it to a higher number. Now add store attribute node and set it to color type and plug our glow color. Call the attribute glow color. Duplicate this, change it back to float, and call this one glow strength. Plug the glow strength input. Now, just like before in the shade editor, we can use those two attributes and use them to control the glow color and strength. Make sure to spell them correctly. Let's take a look at a bit more complex shader. In our presets, we have a few fluid noise effects. All of those were built using this shader group, fluid noise tail shader group. I drag and drop it into the setup. You can see here it asks me for tail UV attribute. Since we already created one, let's plug it here. It also asks me for another one called timer. You will find this timer attribute in almost all the GeoNode setups in the EngineFX pack. Since we're creating one from scratch, let's see how we can create this attribute in the geometry node editor. So I add another store attribute node and call it timer. This attribute will store the current time of the animation in seconds. So inside the geometry editor, I add a scene time node and plug the seconds into the timer. Then back in the shader editor, I access that attribute and plug it here. Now I can view our fluid noise like this. Here we have these options like speed, noise scale, distortion, and etc. It is a slightly bigger setup, but not that difficult, so let's see how you can create on your own. I duplicate the tail UV's attribute just to access it easily. Just like before, I separate the axis and use a color ramp to adjust it like this. Then use a multiply node to combine them together. Basically, to create the setup, what we are going to do is we are going to distort our tail UVs. For that, we can use a noise texture. Use a color mix node to mix it with the original tail UV's vector. Linear light blend method will work fine for this. Now when you change the factor, you can distort it more and more. You can adjust the distortion settings from the texture. Change this to 4D to get this 𝒊𝒂𝒂. Plug a texture coordinate node as well. I use our timer attribute for W. And when I play, you will see our noise is changing in real time. Now it is all about polishing the noise effect. Here I duplicate this color ramp and increase the contrast a bit more. Then I will add it to the previous gradient. What if you want to speed up or down the noise motion? For that, I create a new value node, call it speed and multiply it with our timer. But I like to have some directionality to noise. Right now it is just changing the noise pattern. I want the noise to shoot outwards. It is easy, we just have to offset the noise texture vector. Use a vector math subtract node. Now when I change this x value, you can see we get that effect. Our noise is moving out. So I will use a combine XYZ node and plug this into 𝒔𝒂𝒂. When the animation starts, our noise will move outwards. Now I can use this setup as our mix shader factor. And just like that, we have basic fluid noise shader effect. Now what if you are viewing this from a side? It's going to look flat, right? What we can do is we can just duplicate our effect and rotate it 90 degrees on x-axis. A lot of old video games use this technique to make trees look 3D. You can duplicate it a few more times if you want, but I will suggest a better method. Let me delete the duplicate first. Okay, here is my method. Whatever you're going to make in Blender, at some point you have to render them, right? And you want a camera for that. What if we make a setup that tells this shape to always rotate itself to face that camera? Then it won't look flat. So let's add a camera and place it like this. You can actually add a track to constraint and mess with its settings to create this effect, but doing it inside the geo node will be much easier. So in our engine effects pack, under custom geometry functions, you see a node group setup called camera facing constraint, which does exactly what we want. Just drag it to the setup. By default, it creates a new camera. Since we already have one, let's delete it. Select our camera from here and plug our geometry. Now when I move the camera, you can see it rotates to face the camera. It is currently locked on Z and X axis and only rotates on X because we don't want to change the direction of the thrust effect based on the camera view. And if you want, you can manually rotate the effect in the viewport as well. By the way, this vector value is here if you want to offset the pivot point inside the geo editor. 99% of the time you probably not going to use it. And if I go inside this group, it is just these few nodes, nothing crazy. I have used this setup quite a few times before, I think, all the way from that hologram tutorial I did a while ago. So we basically created our own thrust effect. But how are we going to start it? Well, you can animate these extracted values, but with 𝒔𝒐𝒔 you have a much better way to do it. If you notice, in our custom geometry functions, we have this setup called 𝒔𝒐𝒔_start_timer. This contains two inputs, start frame, duration, and two outputs, start and duration. In start frame, you can define when the engine going to start or when your thrust animation going to start. And in duration, you can tell how many frames the initial animation going to last. This start boolean outputs tells you whether the engine started or not, and this duration goes from 0 to 1 during the time period we set here. So right now our engines will start at frame 10 and the initial animation is 25 frames long. I drag from this duration and search for mix node. Set the value A to 0 and plug our length to value B. Plug the result to length. Now you can see our length will increase for 25 frames starting from frame 10. And if you don't like the linear flow of the animation, use a float curve in between and change the flow of the animation. And if you want to change the start frame or duration, just do it here. And if you're wondering how this setup was made, again, it's a very simple setup, not difficult to understand at all. We check whether the current frame is greater than or equal to start frame and output true or false. For the duration, we subtract the start frame from the current frame, then use a map range node and use the duration value from 𝒚𝒐𝒎𝒆. This will give us that 0 to 1 value. So that's how these procedural engine thrust effects were created. In this tutorial, I tried to cover every basic knowledge you need to create your own thrust effect. You will have access to almost all the necessary building blocks in the free version of our engine effects, so you can create your own presets. If you like to purchase the full pack with already made presets and much more building blocks, head over to Blender Market or our Gumroad page. It's been a bit long tutorial. I hope you learned something cool, something new. I mean, that's what we like to do. We not only create stuff, we let you create with us.